Hi, welcome back to CMG-MathSpace. Still on our core math tutorials for SHS students, we are tackling properties of set operations. We did tackle commutative property, and then now we are going to deal with associative properties. Now, for the record, we did a conceptual video capturing the concept as to why these operations are done before jumping into the calculations, the practical aspects of it. So I recommend that you watch from that before jumping to commutative and then finally associative. Now, we are also doing a series. This is actually a series. So for better understanding the concepts, please start from part 1 if you really want to take this thing very serious. So that is it. Now, let's see what this associative property is telling us. What does it state, or what does it say generally? Right. It's saying that when combining more than two sets, we have set A, set B, set C, right? How you group them doesn't change the final results. What do you mean by this? Let me show you something. Right. Check here. We have, and these operations are basically done on union and then intersections, right? Operations. So you check here. We have A into A union B, bracket closed. Then we have union C, right? This is one side of the equation. Now, when it comes to the other side, it's telling us that this whole thing is equal to the right side of this, right? And this is saying that A outside A union into bracket B union C, sorry, right, is equal to here, and here this is equal to here. What do we mean by that? What it means is that whenever you are given a solution or a question to solve, if you solve this the left side separately, the result that you get will be equal to this when you solve this one also separately. That is the main idea. Don't get it twisted. That is the main idea, right? That's the main idea. So, and the operations on one particular operation, and this is union. So here we are dealing with only union operator, right? You see into here, you see A union B, outside U C. That is it. Now when you go to the other side, which is the right side, you're having A union into B U C. That is it. So if you were given mathematical calculation to do, if you solve here, if you should get 1, after solving here also you should get 1. That is the idea. Now let's move to the other side, which is what we are dealing with. What the intersection I told you is one operator, here too with one particular operator. So here into A intersection B, bracket close, then intersection is gain and C. We are saying that if you should solve this separately on intersection and you come and solve this one also on intersection, the answers or the answer should be the same. Don't get it twisted. If you are not getting the same thing, then that is wrong. You were not able to prove that. So in order to prove that, that is what we are going to do, or show you how this is actually done with practical questions or example. Right, now let's see the examples that we were given. We have set what? Set B, set A, right? Which is what? Has element of 2, 3, 4. 2, 3, 4. Now when you move to B, we have 1, 3, 5, 7. Now move to C. It's what? 3, 4, 5. So this is it, because if you look at this typical formula, where you have how many sets here? A, B, and C. The same thing is applicable. Now, these letters are just variables. It can be replaced with any other variable or letters or numbers or any symbol, right? So that is, don't be static with these symbols so that you get confused. So the important thing, the elements in the set, that's what we are dealing with. Now that we have given the elements of each set, now the first question, right? We are going to prove that if here is equal to here, and then this particular side is also equal to this side, That's what we are. That's our main focus. So the first question, I, is what? A union B. A union B means we are just combining or joining the element of A and B, and that's where we have 1, 2, 3, 4, 5, 7. Sorry. Now let's move to the other question that we were given also. B union C. Make sure you get them right. If you get one element wrong, the whole of the question will be wrong. You won't be able to prove that. So take your time, be pausing the video, and then take proper assimilation. So B union C, we are still combining B and C. That's 1, 3, 4, 5, 7. Good. Now let's move on to II. The II is saying that we are looking for A into A union B, bracket close, then union C, and then we move on to A union into bracket B union C. Right. So the first thing is to solve this particular one, right? This first one before moving to here, this side. So now, anytime you have numbers or variables or any sets, any problem, right, to solve, make sure you tackle whatever is in bracket first. Bracket first before combining with other formulas, because that's the main formula here. This is the formula here. So always do that, else you get it wrong. You remember your board mass. Now, if you have been given A into A union B, and then A union A and C, and then U C, what are we going to do first? Let's do what is in the bracket first, then later we'll bring U. So we already know the set at the top here, so we are just combining them. So A union B is 1, 2, 3, 4, 5, 7. Now that we have this, let's bring down the U. UC. Combining, still combining. 1, 2, 3, 4, 5, 7. So now you get the answer. So now we have dealt with this particular one, the whole of this. Right. So now let's move on to this side, which is A union into bracket B UC. Right. So okay, so you have done this already. So now let's move here. A U into bracket B U C. Right. So now let's do, like I said, we are anytime you have been given a question to solve, deal with the brackets first. That's the best way to start. So now that we have B sets and then C sets, let's combine them. 1, 3, 4, 5, 7. Right? So we can see that now combining all of them from the top here, we have 1, 2, 3, 4, 5, 7. You get the point. So we can see that A U into B U C is giving us the same vibe as what is here, right? And this was this, and now we are seeing it here. So what does this tell us? They are associative. It's as simple as that. If you continue to be solving these, you see them here, right? That is it. Now looking for, I think they gave us some other subsequent thing to solve. A intersection B and then B intersection C. We have A intersection B is 3. You can look at it from the set, the separate or individual set. Now B intersection A, it's like here we are seeing commutative here. It's 3. It's as simple as that. So we can see that A intersection B is equal to B intersection A, which is 3. It's as simple as that. So continuing with the rest of the question, we can conclude that intersection and union of sets are both associative, right? Looking at or solving the rest of the question from V to VI, we can see that these things are associative. So we will see in the next one. Ciao for now.